So for this assignment, let's walk through this implementation of NanoGPT, starting with the foundational components. Our first section begins with the essential imports from PyTorch, and next we define the GPT config class. This is our configuration hub. Think of it as the control center for our model, which stores all the hyperparameters that define our model's architecture and training behavior. We also got parameters for vocabulary size, sequence length, embedding dimensions, number of attention heads, and various training parameters. Moving to the text dataset class, this is where the rubber meets the road for text processing. It handles the conversion between raw text and the numerical format our model needs. Notice how it creates a character level tokenization system by mapping each unique character to a numerical index. This class also handles the creation of training examples by sliding a window over our text. And coming to the multi-head attention class, which implements the famous attention mechanism that made transformers so powerful. You can also take a look at how it splits the input into queries, keys, and values, then computes attention scores. The masking ensures we maintain causality and the model can only attend to previous tokens and not the future ones. The feed forward class comes next. This is a simple but crucial component with two linear layers with a ReLU activation in between, followed by a dropout. And also it processes each position independently, allowing the model to transform the representations created by the attention mechanism. And the block class combines these components into a transformer block, and each block contains attention, feed forward layers, and all important residual connections and layer normalization. These help with training stability and information flow. Finally, we have our main simple GPT class, which brings everything together: token embeddings, positional embeddings, a stack of transformer blocks, and the output head. Notice the generate method that handles the actual generation process. So let's try a new example. Looking at the example, we see how to put this model to use, and we are using a small excerpt from Alice in Wonderland as our training data. So this right here, and the configuration is scaled down for demonstration purposes. Smaller embeddings, fewer layers, and a shorter sequence length than you'd use in production. Watch how we split the data into training and validation sets, create our data loaders, and set up the training loop. The train model function handles the actual training process, including the evaluation at regular intervals. For the first one, I have used very few intervals with very few steps, and hence the output is not that great. But then I increased it to 2000 from 500, and the interval size from 2200. This output is pretty good, especially considering that we have built a very small LLM. And coming to the case study, this part demonstrates a more practical application using the Hugging Face Transformers library. And the important consideration when working with transformer models is the training data here switches to code, and we are using Python functions as our training text. Look at the dataset preparation. We are using the Hugging Face datasets library for convenient handling of our training data. The tokenization process is more sophisticated here, using a pre-trained tokenizer from Distill GPT-2. And the training setup is particularly interesting as we are using the Hugging Face trainer class, which handles many training details for us. And you can also notice the careful configuration of training arguments, things like batch size, learning rate, and gradient accumulation steps, which are crucial for stable training. Finally, we have the generation testing section and the generate code function, which shows how to use the train model to generate new code snippets. The generation parameters like temperature and topic control the creativity and reliability of the output. And now let's take a look at the output. So this here is the prompt that I gave just to build a function called calculate sum. You can look at that here. What okay, yeah. So this is the another prompt where I asked it to give a function for check whether a number is prime or not, and this is the generated code. So that's it for this assignment. Thank you.